Hi guys. So today we're going to transition into something new. We're going to start to look at vectors. Now vectors are something you probably have seen in physics. So we're going to start off today kind of introducing them, finding some parts of them, and then we'll spend a little bit of time with operations and applications after that. So what a vector is a line segment with direction. And that's what makes it different from just a regular line, because you have a direction that it's going. Mass and temperature are what we call scalar quantities, because they really only have that one component, okay? It is the mass in kilograms. It is the temperature in degrees. But things that you did in physics, like velocity and displacement, those are examples, of vector quantities, because they include direction. So it's not just how fast you're going, that's your speed, but velocity shows your speed and your direction. Displacement, again, it includes that direction in it. So we have a lot of components of vectors we're going to talk about. One of them is magnitude. So the magnitude of a vector is its length. Okay, the notation that you're going to see is kind of these little double bars that kind of look almost like two absolute value bars. So that's the notation. You also will typically see a vector with a little like kind of half arrow above it. That way we know it's not just a regular old line, but it is a vector. We'll also find direction. So direction is going to be the angle that vector makes. Basically, if you think about 0 degrees on your unit circle. So how many degrees away we are from that 0 degree. But where that is, really, that's the positive x-axis. But think 0 on your unit circle, what we're kind of used to using. So a vector is in standard form when it starts at the origin. So this is just a little bit of background about them. So what we're going to do is we're going to look at a vector and actually find some of these pieces that we're going to talk about. So vectors have an initial point and a terminal point. The arrow helps us see where we start and where we end. So the initial point, that's the head, that's the starting point. Okay, whichever one you want to use to refer to that. Where the terminal point, that's the tail or the end. It's where the arrow is. So here, this first point here, that would be our initial point. Whereas where the arrow goes, that would be your terminal or ending point. Vectors have both an x component and a y component, a horizontal and a vertical component. So this vector, it kind of goes at an angle. So it does have an x component if we look at the distance horizontally. So that distance I just kind of put there with that, let me change colors. Let's make that blue. Okay, that distance right there, that is the x component of that vector. It's how far it goes how far it goes side to side. So it's the horizontal distance. Whereas the y component, okay, very similar. Again, it's diagonal, so it's saying how far it goes up and down. It's that vertical distance. So if I were to, again, kind of draw a little straight vertical line from that ending point, that would be the y component. A lot of times we're going to write vectors in what's called component form. So component form is basically the x comma the x component comma the y component, but we put these little kind of pointy brackets on the outside of it. So where it's not an ordered pair, that's how we know it's a vector as opposed to an ordered pair. All right, then the two pieces we just talked about, the magnitude and the direction. So the magnitude is the length of the vector. So that distance there is the magnitude. The direction, okay, is, again, which way it's going, okay, which way it's going. So from 0. So on this particular example, that degree is right there, that theta, okay, that would be my direction. And we're going to write these in degrees. We're going to focus on degrees for this unit, so getting away from radians a little bit. All right, so now let's go ahead and draw some of these to get used to them. So we'll look at component form and we'll also look at magnitude and direction. So we're going to see both those things today. So if you have a magnitude of 2 and a direction of 24 degrees, what we're going to do is we're going to draw that 24-degree angle, okay, which we know would be in that first quadrant somewhere like that. Okay, so that's 24 degrees. Then we want this length of that to be 2. So that is 2. Again, if you just label it, that's okay. But that would be my vector. All right, the next one, vector has a magnitude of 3 and a direction of 100. So let's go ahead and draw, again, a 100-degree angle. So we start at 0, and we go 100 degrees. That's going to be a little bit past 90, and that length I'll just label as 3. All right, let's do component form. So remember, this is an x distance and a y distance. So what I'll do is I'll start at 0, and I'll go over 3 and down 2. So my vector would start here and end there. Now the interesting about this from component form, the one I just drew was the one that's in standard form. But technically, if I wanted to, I could make this vector over here and go right 1, 2, 3, down 1, 2. And that vector, even though it's in a different location, still has that same component form. But they're a little bit easier for you to start at 0 and draw them in standard form. All right, let's try this next one. So we're going to go left 5 and up 8. So left 5 and up 8 is my ending point. Start at 0. And that is my vector. Now what you'll notice here again, the negatives kind of help you see the direction. Because I'm going left, I have a negative x over here. Because I went down, I have a negative 2. So keep in mind, in component form, those negatives help you see that direction. All right, so now we're going to take a picture and find component form and magnitude. So we'll start with component form. Remember, we need an x and a y. So starting here, ending here, let's find the horizontal distance. And in this case, we can just count. We've got 1, 2, 3, 4, 5, 6, 7, 8. So the x component here, I went right to 8. The y component, from the start to the end, I went down 2. So I am going to write that as a negative 2 for that component. All right, let's look at the next one. Let's find our x component. So I went 1, 2, 3, 4. And I went up 1, 2, 3. So that's my component form. We're also going to find magnitude. So magnitude is the length of the vector. Now, if you think about it, if you know the horizontal distance and the vertical distance, it's going to be pretty easy to find the diagonal distance because that's a right triangle. So all we need to do for magnitude is Pythagorean theorem. So magnitude, that's your notation, remember. I would do a squared plus b squared equals c squared. So c would be the square root of a squared plus b squared. So let's go back to both of these, all right? We're going to do the square root, the magnitude here would be the square root of 8 squared plus negative 2 in parentheses squared. Okay, we do have to put it in parentheses because we're never going to get a negative in the square root. So that would be the square root of 64 plus 4, which would be the square root of 68, which we can reduce by taking out a 4 and make that 2 square roots of 17. All right, let's try the next one. Again, to find the magnitude here, Pythagorean theorem. So the square root of 4 squared plus 3 squared. That would be the square root of 25, which is just 5. That's one of your triples. So magnitude really is just Pythagorean theorem. All right, so now let's talk about how to kind of go back and forth between our given information. Typically, you're either going to be given component form or you'll be given magnitude and direction. And we want to know how to go back and forth between these two things. So if I'm given component form, that means I'm given A and B. Well, magnitude, that's what we just found. Okay, magnitude, we would use Pythagorean theorem. A squared plus B squared is C squared. So my C here, that's my magnitude, would be the square root of A squared plus B squared. Now let's think about how to find direction. All right, direction would be this angle. If I know A and B and I want to find that angle, I can use a trig ratio. I've got opposite and adjacent. So I could do the tangent of theta is equal to opposite over adjacent. Now to actually find theta, if we're looking for an angle, remember we use inverse. So then I would write this as tan inverse B divided by A. Now the one thing you do need to be careful about when we find direction, keep in mind the calculator is either going to give you, if you plug in a positive number, your calculator is going to give you the answer that falls in this quadrant. If you plug in a negative value, the calculator is going to give you the answer that falls in this quadrant. The reality, though, is some of these vectors are going to end in quadrant 2 or quadrant 3. So in order to get those answers based off the calculator, if the vector is in quadrant 2 or 3, okay, if the x is negative, if the x component is negative, then what we need to do is we need to take the calculator answer plus 180 in order to be able to get that quadrant 2 or 3 answer. That's probably the trickiest thing about this. All right, now let's look at the other information. Let's say I know magnitude, and let's say I know theta. Well, if I want to find the x component, okay, I'm trying to figure out how to find this. I again can use trig, okay? If I know my angle and I know this distance, that's a right triangle. So I could set up a trig ratio. I could do cosine, for example. The cosine of theta would equal the adjacent over the hypotenuse. So if I solve for x, I would get cosine theta times that magnitude. So the way I'll write it, I'll write magnitude first so we don't accidentally include the magnitude as the angle. But the x component here would be magnitude times cosine of the angle. Let's say I want to find the y component. Very similar, I would set up a trig ratio, except this time I've got opposite in hypotenuse. So sine theta is opposite over hypotenuse. So my y component would be magnitude times sine theta. And this is probably going to seem pretty familiar with you guys. X goes with cosine, y goes with sine. We've done that a lot this year now. So if I write this in component form, pointy brackets, x, comma, y. And that would be the component form. All right, so we're just going to do a couple examples doing this, and then we'll wrap it up for today. So let's start with magnitude and direction. So I want to find component form. Component form means I want an x comma y. So let's start with x. Okay, x is magnitude, cosine, direction. Y is magnitude, sine, direction. So what I would do here, I would do magnitude, cosine 166. And for y, I would do magnitude, sine 166. At this point, we're going to have to use a calculator. So let's go ahead and get a calculator if you don't have one. One thing you want to make sure of on your calculator is that your mode is in degrees, because we are talking about degrees. So your mode here should be in degrees. But at this point, these are things you can just plug into a calculator. So you actually have to plug it into a calculator. We don't know the cosine of 166 without one. So if I plug that in, I would get negative 2.91, comma, 0.726. So that is the x component and the y component. All right, let's try another one. Magnitude and direction. So my x component would be 2 cosine 120. The y component would be 2 sine 120. And now at this point, this one actually you don't have to use a calculator for, because that is one of your unit circle values. But if you use a calculator, that's okay. We are going to have a calculator for this whole unit. So 2 cosine 120, if I plug that in, I would get negative 1. Or if I just use my trig values, okay, remember cosine of 120, that would be the x-coordinate at 120, which is a negative 1/2. But it's okay if you use it on a calculator. Sine of 120, that would be root 3 over 2. Or again, plug the whole thing in, and you get square root of 3. So writing this in component form, pointy brackets, pointy brackets. And again, if you think about it, this should make sense. Think about where 120 degrees is. 120 is over here. So you should have, in order to plot this, you would have a negative x and a positive y, which is what we have. All right, so the last thing that we're going to do is we're going to go the opposite direction. So we're going to take component form and find magnitude and direction. Well, magnitude, we've already done that now a couple times. Hopefully that's pretty easy. I'm going to draw this out, though, just in case we need it. So 3, 4. Right 3, up 4. There's my component form. So my magnitude, Pythagorean theorem, the square root of 3 squared plus 4 squared, which is 5. To find that angle, we're going to use trig. So tan inverse. Theta is equal to tan inverse y over x, opposite over adjacent, 4 over 3. Plug that into a calculator and you will get 53.13 degrees. We don't need to worry about the adding 180 because it's in the first quadrant. And if you look at that picture, that looks like a 53-degree angle. All right, last one. Again, I'm going to draw this out to help a little bit. So -5 up 12. So something like that. All right, so let's find our magnitude. The square root of -5 in parentheses squared plus 12 squared. That's one of your Pythagorean triples. That's 13. Then we'll do our angle. So tan inverse y divided by x. So 12 over -5. If I plug that into a calculator, I'm going to get a -67.3, I can't read my handwriting, 8 degrees. Now, if you think about it, this doesn't make sense. Hopefully that's a good reminder that we have that additional step here because we're in quadrant 2. Think about where a -67-degree angle is. If I go backwards 60 degrees, I'm going to be over here. That's not where I drew my picture. So I have that extra step because this is in quadrant 2, because the x is negative. We have to take our calculator answer plus 180 to get our actual answer, which is 112.62. Which again, if you look at your picture, that makes a lot more sense. That looks more like a 112-degree angle. All right, so that is it for vectors. Next class we'll do a couple operations with them, and that is it.